Do I need to repeat the joke, or will you laugh without me? I need to repeat the joke, okay. So the joke was that I was planning to start late, to say that we start so late that you need to leave the room and say, oh, it was so funny and there were many jokes and I learned something. But now it's actually going to happen. So remember, when you leave the room, you say that you learned something and that was really funny. Ha ha ha. Good job. So about me, the spoiler that you already received, I studied computer and software engineering. My dream job as a student was to work for NVIDIA and to develop sophisticated things for parallel programming and all kinds of GPUs. I was working in Intel as a student, and then I moved to Berlin. And the biggest problem of Berlin is that it has lots of cool startups and a great software industry and really, really, really low number of hardware startups. So I had to switch into software, and that's how I actually started using Go and Elastic. I also started co-organizing the GDG chapters for Berlin for Golang and for women Techmakers. And this year, I decided I should do another organization, so I'm organizing the GopherCon Iceland conference, which is for Go developers in Reykjavik. I don't work in Elastic. I just really like it. And that's our plan for today. We're going to see how the Elastic Stack was developed and what was going on there. We'll see why is it good, who is using it, and we're going to do some fun hands-on. I have candy for those who will answer. I also have candies for those who will fall asleep. That's the guy next to you. I see you're almost halfway there. So what's the Elastic Stack? It's a set of open source tools, and they serve different purposes. Essentially, they're there to make your life better. So they offer you things like storage and search and analysis and visualization and security and logging and monitoring and reporting and alerting and even machine learning, all kinds of ways to process data. And so we said that we'll start with a timeline of how the Elastic Stack grew. So first thing was this distributed search and analytics engine that you can use with a REST API. And that was developed in 2010. And the reason that it was developed is that the person behind this moved to the UK, I think, with his wife, who was a cook. And he was a software developer. And he wanted to find a cool way to help her handle her recipes. So like, I know there's lots of databases, but let's make this one, and it's really cool. And I will show you screenshots of each product, but remember, we say this one is REST API, so that's how it looks. Who is familiar with this syntax? Raise your hand. Who is not familiar, raise your other hand. Half, okay. So there are several ways to communicate over the internet. You can do put, get, post, delete, update, several others. This is essentially a request. Post is the type of the request. What you see following after the localhost is the URL, so this one is local. And then what you see in curly brackets is the body of the request. So this is how I add things to the database. What you see in this slide is that I'm inserting a document, and the content of the document is a person. His name is John, his last name is Doe, and this is his job description. He's a sysadmin. And once I do this API call, I get the response on the side. It took this long, it didn't time out, all kinds of data, and hey, great success. And this is how it looks if I wanna get. So I do search. This is the slide I was looking for. Just gonna skip. I'm gonna do get by ID. So this one is a get call, not a post call. It doesn't have a body. I'm doing it to the same address. I'm going to localhost, and I'm saying under accountants, go to person with the ID number 1. And that's how the response looks like. It took this much time, this were this many hits, and yeah, this is your person. This display is confusing me as well. I'm going to look like this with you. So what's happening here is that we're doing another type of search. This one is we do search with a body. So you see this is, we say, aggregate this information and all kinds of parameters. And I'm sorry, it was a bit jitty. Let's pretend this didn't happen. Now we're going to get by name. We're going to do another get query, and we say that our parameter is John. This is the part of Q equals John, and then this is how the response looks like. We're getting some results, and on the left is the results, on the right is actually the content. And then we do get again by name. Previous one was by ID, I want to say. And it gives you the results. Now we want to do aggregation. So let's say I have many results. I want to display, let's say I have 10 employees named John. Some of them have the same last name, some of them don't. Let's pretend. So let's say I want to aggregate by last name. I will say, give me a questionnaire with all the people with the first name John, but the last name something specific. And then you can get kind of buckets and some results into each bucket. And again, you will get a response. And then usually this response will go into your web server, and you'll actually process it to display some nice way to your users. The year after came Logstash, which is a processing pipeline, and it basically gets you handle lots of data. And as the name may suggest, it's mostly used for logs. I was trying to find a nice way to present you this as well, but it's also really pipes behind the scene. And so this is how the data that is being eventually sent is being presented. But to be able to visualize it, you're going to need a visualization tool like Kibana that was joined in 2012. And Kibana lets you create with the data that you inserted and analyzed with Elasticsearch based on whatever you received with Logstash look like this. And you can have numbers, or you can have all those pie charts or donut charts. You can have bar charts, you can have it by geo and other cool ways. And most of the monitoring screens you see is there. Who here is watching, how's it called? This TV show about hackers from Netflix? Mr. Robot. So remember when Elliot was in his booth and he was looking at this screen where somebody actually catch him? That was Kibana. He was actually working on it with the Elastic team. It's pretty cool. It was on TV. Yeah, so Elasticsearch, Logstash, and Kibana together, they formed the ELK stack. And the ELK stack starts, as we said, with collecting the logs, then searching and analyzing them, and then visualizing and managing. It's worth saying that while logs is a very common use for that, you don't only have to use logs. You can take from Elastic and Kibana and drop the Logstash part and process pretty much any data. The company for which I work now, what they do is they take lots of metadata from different files. So let's say you have an image, right? And you know that image has lots of information like the location it was taken, or the type of a camera, or the date, and so on. And then you take that from an image, and you take lots of similar information from a video file or maybe a text file, and then you put that all into our Elastic database, and then you can search that. Many other companies, as you'll see, are using the same thing. 2015, they kept developing, and then Beats was acquired by the Elastic stack. Beats are based in Berlin, and they're pretty cool. They're using Go as well, while Elasticsearch is actually in Java. And what Beats does is basically it's shippers that you can put anywhere you want, and it's agents that are sending data for you to process. And that's how it fits into the stack. So you can take the Beats packet itself, or you can take the API into pretty much anything you want from Windows events, log files, metrics, and whatnot. And then you put that into Logstash and Elastic, and then you can keep processing your files. In 2016, they took a bundle of features, things that can do alerting and monitoring and machine learning and security and whatnot, and built the XPack, not to be confused with the X-Man. And then this is how it looks. Eventually, you can basically take each instance of yours and add different features from your XPack bundle for it. In 2016, they decided to go cloud. And then Elasticsearch and Kibana are now available basically from any cloud. You don't need to think of the setup locally anymore. And in 2017, same thing happened for enterprise. And when you want to handle it, this is how it looks. Now that we added the beats and the XPack and the cloud, this no longer was the ELK stack, right? ELK, we said, is just Elasticsearch, Logstash, and Kibana. This is how it became the Elastic Stack, which is what we're going to talk about today. And this is kind of how it all goes together. So you take information from Beats or from Logstash or from another source. You process it using Elasticsearch. You analyze it. You can use all the different XPack features, like monitoring or like security or like machine learning and so on. And then you take it into Kibana, and then you get a nice visualization of all your data. The next slide, I think, is not going to be too visible. Yeah, that's the timeline. It's a very cool picture from the Elastic website. It basically shows you, this is the first part of the timeline. It shows you the way Elastic developed while things like we went to Mars. I think my microphone died? No. Yeah, lots of progress of science versus Elastic. And you can see that every year new stuff are added, and it's nice development. And that's how it looks all together again. Go to their website to look at this. Now, let's talk why not SQL? What's the problem, right? We all learned this database, we all love it, or not? And the answer is that Elasticsearch is perfect for text search. When you have a document structure that is not key value, but a very nested and complex way in a JSON format, Elastic is built exactly for this. And it lets you search in a quick way, whether you do a fuzzy search where you don't look exactly for the term, but maybe accept typos or similar words, or if you do exact search. It even has a built-in highlight, which we'll see that some websites already use. Like who? GitHub and Facebook and NASA and B.Sc and Docker and Facebook and Tinder and Stack Overflow and eBay and Dell. And this is just a very short list of companies who are using Elasticsearch for the search part of it. This is how it looks on GitHub. You see the highlight part? Built in Elastic. That's nice. This is how Facebook is utilizing Elasticsearch. They do it in their help section, and it helps you find the things that are most relevant because it also organizes things by relevancy. The way that Elastic does it is that they have this inverted index, which is an interesting calculation that doesn't simply decide that the most relevant document is the one that has the term that you're searching the most, but actually it counts the number, the time each word shows up generally, and then how many times it shows up in that document, and then it does like one divide by that, and kind of calculates how rare a term is. And this is how it defines how relevant a document would be. And this is an example how eBay is using this. And you can see from the screenshot that not only it returns you the relevant things like chairs, but it also returns you similar words, which is also a built-in feature of Elasticsearch. And you can see that it returns a chair and a stool and a sofa and whatnot. Companies that are using Elasticsearch for monitoring or the Elastic Stack. Netflix and Slack and Cisco and Volkswagen and T-Mobile and Uber and Mozilla and GoDaddy and Microsoft. It's really anywhere. If most of you are students, this is the thing you want to probably learn now. And a good way to learn would be to have some terms, because everybody likes that, right? Saw somebody in the crowd with a laptop. Maybe you can type it. So the first thing we have is a node, which is essentially a server. And then we have a cluster, which is a set of servers. And when you do a search, it searches across all the nodes. So far is okay? Make sense? The next one is the tricky part. It's the way the data is actually built inside Elastic. So a document is how we call this basic unit of data. And a type is kind of, if you take some common ground for a set of documents, this is your type. And a higher level of similarity would be your index. And then for a while, Elastic were using the analogy that index is like a database and type is like a table, but this got many people confused. And moreover, it got many people to think of their Elastic database in the term or in the sense of SQL database. And then it got them to use it wrong or not really utilize the features. So have a very, very small relation to this analogy and mainly try to think in terms of index and of type. And then the last term is a shard, which is a subdivision of the index. And then just to go into the guts a little bit, each search is done in the shard separately and then it returns all together. This implies all kinds of things on the right way you will partition your data, which is sometimes an interesting debate in different companies who think how should we define what's a type and what's an index for us. And if you are curious about this, there's a lot to learn. Just Google. And now we're going to do some hands-on. I'm going to need you to participate. Remember, we have the candy. So I decided that what we will be indexing is literature. Can you give me 3 names of authors? Let's see if we thought the same 3. Let's start with one. Who is one person that comes to your mind when I say literature? Tolkien. Cool. I don't think I can repeat that. Okay, J.K. Rowling. No. So those are the 3 that came to my mind. Shakespeare and Szymborska. Yeah? By your giggles, I get that. And Dostoevsky. And they are our authors. Remember that. We will start partitioning our data. Focusing on Shakespeare, what are some famous acts of him that you know? Hamlet. Macbeth. Yes? Yes. So we were thinking the same. Nice. So those are the 3 acts of him that I chose. And then, just to check your general knowledge, because I was curious, give me 3 poems of her. Szymborska. Let's start with one. You all Polish here, you should learn this in school, no? Well, don't you learn this in high school? I see. Well, let me remind you. Utopia and possibilities and the joy of writing. And, well, Dostoevsky. Crime and Punishment. Demons and the Idiot. Those are some books of him. And then, so we said that we have the 3 authors, and then the higher, that would be kind of the higher level of partitioning for literature. So that makes each author to be an index. Does this make sense so far? Less heads nodding, but at least sounds good. So Shakespeare has acts, and for each act, you can separate it to different things. I chose to separate it to 3 types: act, scene, and line. Those are our types. And then each one of them is going to be a document in our database. Okay? So now we're going to do this hands-on part. I'm going to give you a snippet from one of these acts. We're going to partition this together, we're going to store this together, and we're going to try to search this together. Are you ready? This is exactly how you imagined your Friday night. Okay. Not going to read this out for you, but yeah, that's our part. And then the first thing we'll do is index a line. Now, the rule for our exercise is that if you have a right answer, you're going to get 1 candy. If you found a mistake in what I wrote, you're going to get 2 candies. Go bug hunting. So, help me fill out the first field, the first key value pair. The full part, the snippet is on the left, so you can use it as a reference. What did we say that our index is? Author. Author is the type of index, but this specific index is? Shakespeare. Who said it first? Are you serious? There's no way I'm reaching there. Are we trying this? Okay. We have help. It's cheating. You can come closer. Everybody in the back can come closer. Okay, so index is Shakespeare. That was a good one. Next one is type. What did we say that we're indexing now? Lines, correct. Who said that? Okay, I'm going to try to do this now. Almost, almost. You can come later for another one. And, well, what's ID should we give this thing? If we start from the beginning, the ID will be? What will be the ID? If you have to index something in your database, what would be? Exactly, 0. Who was that? Okay, I have some help from the crowd, but good. So we have the first part, and now the second part of our JSON is actually the content of it. So I already gave you a spoiler that the line ID will be 1. What will be the name of the play? It's okay, I understand if you don't recognize Hamlet. What ID should we give to the speech? Let's say 1. Who is our speaker? This one's easy, it's on the screen. It's an easy candy. Who is the first speaker of this snippet? Bernardo, bravo. That was somewhere there. Great, and then what is the text? Great, who's there? Yo, good catch. Great success, we indexed our first line, let's index our second line. Now that you got this, it's going to be faster. Now I also have helpers in the crowd giving away candy. So, what's our index? It starts with Shakespeare. What's our type? Line. What's our ID? 1. If we do 1, we're going to overwrite. If we do 0, we're going to overwrite the previous one. Line ID 2, play name. Hamlet. Speech number. Still 1, right? It's the same speech. Who's the speaker now? And what's he saying? Well, it's a fun line to say. Nay, answer me. Stand and unfold yourself. Good. Now, the next type we're going to index is a scene. What's our index? Shakespeare. So index is the verb, but it's also the name of it, and it's confusing, but you need to remember the terminology. Shakespeare. What's our type? Great job. What's our ID? Great. What's the line ID? Good job. It's 1. What's the play name? Hamlet. Speech number? Still 1. What's the line number? I think this is, if anybody caught this before me, you deserve 2 candies. It probably doesn't make sense to have this for a scene, right? Speaker, this guy, and, well, text, actually, the entire thing. Those 3 probably don't belong there. Anybody feels like vouching those 2 candies, it's okay. Now, we're going to index an act. So again, what's our index now? Shakespeare. Still Shakespeare. We stayed to the same guy all this time. You can see on the left, it's the same snippet. Didn't change. What's the type? So we said we're going to index an act. So the type is? Good job. What's the ID we're going to give to the act? 0. What's the play name? Who are the speakers? Bernardo and Francisco. And what's the genre? Drama. Good job, everyone. We just indexed 4 documents. You really get this Elastic thing going on, huh? Rolling with it? Don't tell anyone that it's slower than the real Elasticsearch. So this part, we're going to do search. Now we just put the documents inside. Now let's fetch them. So this is how a search request looks like. It's a post request to the endpoint with the index Shakespeare, with the type act. And we say make a search. As you can see, there's an underscore before, so it means it's a command. That's how Elastic interprets that. And then we, in the body, in the curly brackets, we say we're going to do a query where I'm going to ask you to do match. There's all kinds. There's filter, there is exact match, and so on. We just say regular match. And the key value pair is look in the field speakers to find the value Francisco. And now a pop quiz. These are the 4 documents we inserted. How well can you see them? No. But you remember the 4 documents we had. We had 2 lines, 1 act, and 1 scene. And our search is Francisco. So try to remember which one of them was there. It kind of ruins the point because I was hoping you will look at it and say this, but I can tell you that the answer is we're going to get 1 act, obviously, because we put just 1 act. And this is how a response looks like. It says how much time it took. It gives us information like how many hits. It gives us information like what's the score of the relevancy. And it actually gives you all the information, which is play name and speakers and so on. Now we're going to look for a scene. And we're going to ask for the speaker to be Francisco. And yeah, from the results, we get the response. And the last fun part is searching for a line. Who remembers how many lines were with Francisco? 1, 0, 1. Correct? So looking at the expected results, here is 1 result. And the information that you probably cannot see, but I can tell you, is that it says the number of hits is 1, the relevance is this much, and here's all the information I have about that one line of result. And another way to display all this information that we were doing is with this beautiful dashboard with Kibana. You just need a little bit more data and more documents to process, right? And well, to wrap this up, I hope this slide makes now more sense to you, because now you can actually imagine taking some data, whether it comes from external data set or from Beats or from Logstash. You put it through Elastic, you process it if you want, and then you can also fetch already information from there or use Kibana to visualize it. And that was it. Thank you very much.